Welcome back to another one of my vectors and scalars videos. This one is on vectors and a vector and scalar addition. This is going to be the first video. This video I'll go on, I won't use numbers, but I'll explain what vector and scalar addition is. So let's start with scale. I'm not adding vectors and scalars together, this is just separately things. So let's start with scalar addition. This will be pretty quick because scalar addition is it's simple. It's like adding 5 and 10 equals 15. You have, let's say you have a magnitude. With scalars you only have a magnitude. Let's say this is a magnitude A, so this could be a number. And let's say B is twice that magnitude, so that's B. That could be like, let's say that could be 5 and that could be 10 sort of thing. So A is half the size of B. Let's do an example. It's just like when you add something on think of it as adding things on a number line. So you start at 0. Let's say we go A plus B. Well, what would that look like? Well, you'd have A. That's a bit long. That would be A. And then you would add B onto the end. Therefore, this is A plus B. Now, example 2. Let's say same with vectors. I got taught this way that no vector. There's no such thing as subtraction. There's always addition. You're just adding. If I went to say this is B, negative B would be the same magnitude, it would just be pointing in the other direction. So it's like saying you have your positive x-axis and your negative x-axis. So pretend this is the vector, that's the tail and this is the head. Like that's the tail and that's the head. This is pointing this direction. This same applies for vectors. When you got a positive value, it's this way. When you got a negative value, it's just turned around. That's it. And to make it easier, let's say you had 5 and you took 10 away. That would be negative 5. So just like that, if we had A take B, that's how we write it because it's faster, but essentially what we mean is A plus negative B. Where A, and we're adding it, what we're adding to A is B, but B's in the negative direction. So it's just, whenever you work with vectors and if you're showing scalars, like representing it like I am showing you, negative just means it's flipped. Okay, when nothing is negative, it shows the direction. Okay, so if up is positive, if it's a negative number, then it's down. If to the right is positive and it's going a negative, then it's to the left. That's it. Or in same, if you made left positive and it was negative, it means it's pointing to the right. Okay. So let's say here we have A. Start at this point. We have A. And we want to take B from it. We don't put it here because that'd be just going head on. So you'd represent it by putting, we're adding negative B. So negative B would go this way. Therefore, this little bit here would be A take B. Okay? This here is, let's say, 0. So if say A was 5, A equals 5, A equals 5, and B equals 10. Okay? Negative B would equal negative 10. So if I had this here, that would be literally the same as going 5. I'm going 5 in this direction from 0, and then I'm going backwards, backwards 10. That actually is supposed to be a positive because it's pointing in the negative direction, therefore it's a positive. Okay. Anyway, so here is 10. It's going this way, 10. Therefore, this distance here must be 5 minus 10, or 5 plus negative 10. Hopefully that makes sense. Anyway, that's basics of scalar addition. Now comes vector addition. So let's go vector addition. Let's say we have a vector. Use the squiggly mark or the arrow, whatever you prefer, just to show it's a vector. And we'll say it's that. We won't worry about the direction or the magnitude. We'll just say that is vector A. Vector B is this. And we'll also have another vector C for a later example. And that'll just be vertical. Okay? So let's say we have example 1, A plus B. That means this plus B. Therefore, at the original point to the final end point, we have A here, we have B here, and this is A plus B. This big arrow is A plus B. That makes sense. Okay, because with vectors, you can actually move them, and I'll show you when we add all these together, that you can, no matter what orientation you have, as long as you have everything connected head to tail, and then you draw the starting position to the final position, it will always, that distance will always be the same, and in the same direction. Okay? Anyway, so let's say we have example 2, A minus B. Well, just like scalars, that's the same as saying A plus negative B. So we're talking about negative in the negative B, in the negative direction. Okay? So A, that's this one. And then negative B. That means we come from here. Oh, we're going to have to go through A, but we come from here and we go like that. And that would be our negative B. This is A, and this is our negative B, pointing that way. And then we connect the starting point to the end point. We go up. And this little vector here is our A minus B vector. Hopefully that makes sense. And I'll draw a bigger scale. That's A. That's negative B. And that's A take B. Okay? Let's add them all together now. So we'll say, example 3, A plus B plus C. Okay, so that will look like you can have them in a couple of orientations. You could have A, then you could have add B, and then you could add C. That means from here to here. This one going right through the middle, the long one, is A plus B plus C. This is C, this is B, and this is A. And this long one is A plus B plus C. You could always start. The good thing is vectors, they have no like real, they have a starting point here and an end point, but you can put them anywhere, which is great. You can like start with C if you want. You can have C go up, and then you could have C, and then you could add B to that. And then you could add A. But when you connect all the points together, A plus B plus C, that's A by the way, this long one should be the same distance and same angle as that. I haven't drawn it obviously, this is just a sketch, but A plus B plus C should be the same no matter what orientation the vectors are in. As long as they're connected head to tail, not tail to tail or head to head, as long as they're tail to head, 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 you're all good. I'll show you one more example that I've done where it's example 4. A plus, and in brackets, B minus C. Okay, that means we want it in a specific setup. So first, we focus on A minus C, B minus C. So this is B, and C is this. Negative C would be going like that. So therefore, we add negative C. This is B, and this is negative C. Therefore, this distance from the start to the end is B minus C, or B plus negative C. Now we take this vector here, and we add it to A. So A comes out to here, and then this one goes down like this, and that's our B minus C. And then we draw the start finish to the end, and that is our A plus B minus C in brackets. That vector there. And that's all I've really got to show you for just how it works. I'll show you the next video that I will do on vector and scalar addition will be with numbers, but this is just showing you how they work and how they're orientated and whatnot. But anyway, thanks for watching. I hope you learned something, and I hope you have a good day.